So thank you very much everyone for coming to the webinar this evening. So just to welcome everyone on behalf of the Parliamentary and Scientific Committee, we're having a discussion on unlocking the potential of robotics and autonomous systems, harnessing technology development, regulatory innovation and ethical considerations to support economic growth, which has been organised in partnership with the Hazards Forum. So many thanks to the Hazards Forum for all of their work and sponsorship. So a very warm welcome to our panel of speakers, each of whom has agreed to deliver a presentation of up to 9 minutes. So in turn, we have Rav Chunilal, who is Head of Robotics and Artificial Intelligence at Sellafield. Then we have Professor Samia Nefti Meziani, OBE, who is Chair in Robotics and AI at the University of Birmingham. And then we have Vaibhav Puri, OBE, who is Director of Sector Strategy and Transformation at the Rail Safety and Standards Board. And each of our speakers has agreed to speak for up to 9 minutes, after which we'll have questions. So just a brief bit of housekeeping. This webinar is being recorded and it will be available on the PNSC website and on YouTube after this meeting. After the speaker presentations, I will invite questions. When it comes to those, please use the Q&A function that you'll all have access to, not the chat button. So that should just be at the bottom of your screen if you'd like to ask a question of the panel. And then I'll call your name and we'll unmute you prior to you asking your question. So without further ado, at this point, I am delighted to hand over to Rev.
Thanks, Sam. Good afternoon, everyone. I'm Rav Chunilal, Head of Robotics and AI at Sellafield, which is part of the NDA group. So my talk is going to touch on, how our team leads the robotics program and pretty much make nuclear decommissioning safer, faster, and more efficient using robotics, and more importantly, how we're leveraging the cross-sector collaboration as well. So this is a very short and sharp whistle-stop tour. So just as a heads up, there are QR codes on some of the slides that link outwards. So if there is anything more or that you want to know and understand, just keep your phones on the ready and snap away as you feel fit. So a little bit about the NDA. It's our parent organisation. Nuclear Decommissioning Authority manages 17 sites across the UK, including Sellafield, which is the most complex, and it's located in what I think is probably one of the most beautiful parts of the country in West Cumbria, just underneath that orange dot. NDA's mission spans across hazard reduction, decommissioning, waste management, and long-term environmental protection. So a little bit about Sellafield as well. Began in 1940s as a Royal Ordnance Survey ordnance factory, and after the war, it became Windscale to produce plutonium as the UK deterrent. And in the mid-1950s, Calder Hall, which was the first commercial-scale nuclear power plant, opened on the site as well. We then went into a reprocessing centre where we were reprocessing Magnox and oxide fuel from across the world. But today, the mission has now changed. So we are now predominantly a hazard and risk reduction waste management site. And it has some of the most complex facilities across the UK and probably in Europe as well. So why robotics and what are the benefits? So I'm not going to read off everything that's on the screen there, but we're already deploying robotics in nuclear environments, and we're already seeing that difference that it's making. And our aim is to continue evolving that into different parts of the site, not just at Sellafield, but across the NDA group too. So there are clear advantages. And we also see those advantages being shared across the different sectors as well. We are involved in cross-sector collaboration over the last 5 years, and you'll hear about a couple of those from Samia and Vaibhav later on as well. But one thing to mention is that through these national collaborations and others like RACO and DASA, which are cross-sector collaborations, they are really making a difference, especially to what we're doing in the nuclear sector. So a few more examples of what we're using robotics for. So on the left, we have got a video of how we're using UAVs and drones in confined spaces. This is one of the cavities of one of our silos where we can't actually send a person because of that environment. So the data that we collect from the UAVs is absolutely priceless. And on the right, I know the image isn't super clear, but that's one of our underwater ROVs operating in our nuclear ponds, which has fuel in there. So these have been used for about 15 years now on the site, for cleaning and moving material around. And these are now routine, so they're part of our baseline, similar to the UAVs. And in the center, that is one of the developments with our supply chain to create a bespoke and automated robotic size reduction system that can cut and decommission skips that we've taken out of our ponds. And the whole point of that is to minimize the exposure to our operators. And these are semi-autonomous too, so once you've understood what type of skip it is, the robot sort of like goes away and does the cutting and the placing by itself. So this is really pushing the boundaries of technology adoption to the next level, especially when it comes to nuclear. So, and we want to continue that trajectory too. So one of the ones I want to mention here is Robo. So this is our flagship, one of our flagship projects, I should say. So this was one of the world first hands out of glove box projects to be deployed in an active nuclear environment with our supply chain partner Atkins and with support from our operators on the site. So yes, no humans hands are needed in those glove boxes, whilst these operations are taking place remotely. And the benefit is to reduce operator dose and risk. So what you see in the video aligns with some of the operations that are undertaken in the glove boxes by our operators. And just recently, we've just developed some new size reduction tooling to be used in there too. And our comms team have just shared some of that online just last Friday. So if you want to know more, just go online and just have a look. So back to cross-sector collaboration, we are one of the founding members of RACO. RACO is the Robotics and AI collaboration. So it's a partnership that brings together Sellafield, NDA, UKAEA, University of Manchester, and as of this year, AWE too. And the purpose of it is to accelerate deployment of robotics and AI onto our sites. So some of the common projects that we're developing and using are on the screen there. That include like 3D data collection, developing a unified robotic control system, and operational simulators too, to help us train operators using those systems prior to them actually using it on the actual nuclear plant. So this is the video that's on the bottom right of the screen there, which shows one of the swarf storage silo operations simulator that's used by our operators. So these videos just show some of the capabilities that have been developed by the program, that cross-sector program, over the last 3 or 4 years, and that's working with academia and the supply chain. So a little bit about artificial intelligence as well. So Sellafield developed its first AI strategy in 2022. And since then, we've developed a few tools and we've prototyped a few as well. So we also developed our first large language model. So it's like our internal chat GPT, if you like. But also what we have done is we've got an AI-based image and video analysis project that aims to characterize the nuclear material that is being moved from the legacy silos. And that early concept work is showing to be really positive and could ultimately reduce the number of waste packages and drive down cost and overall risk as well. But there's going to be more to follow on this, as that work continues. But what it does do is it's converging science, fluid dynamics, and AI. Probably one thing to mention here as well is that we are working with our regulators quite closely. So that's the Office for Nuclear Regulation and the Environment Agency, just to test new ideas in what we've called the sandbox environment. And what that does, it helps us sort of like share those ideas and discuss them early on before we get to deployment. And what that does is increase the pace at which we get things deployed onto our site as well and avoids rework. This year, we've predominantly been looking at how we use machine learning and deploying AI more securely onto our networks and maturing the sort of governance and the ethical use behind it as well. So we've done a lot of work on that, and we're continuing to do that next year as well. Some of our teams are also working with our safety case teams on how do we use AI to help us draft safety cases as well. Again, we're working with our regulator on this as well. So we're being completely transparent about how it can be used and where the benefits lie as well. Okay, so what I've just shown here is, some systems approach that can be taken from the component technologies that I've just shown here. And I think that's where the true value can be harnessed out of what we're doing and developing across the sector. So there's a little video here which shows a blimp or a UAV doing a scan of an environment, collecting some data and sending that to a digital control hub where the operators are then looking at that, checking it against the models and plans, making sure the approach is correct, and then asking the robot, transmitting it to the robot to undertake that task. And in this case, it's to a robot that's going to be scabbling a wall or a surface, and that waste that's being scabbled is then sent via a vacuum to an area or into a package, which is then collected by a quadruped robot, handed over, and that waste is then characterized. So to build up the knowledge as to where it's come from, etc., so it can be processed and be kept in the database. So once that's ready, what will happen is you take that to its final form, which in this case it'll get compacted into a puck and then put into interim storage where it can then continue to monitor. So the reason why I wanted to show this is imagine this system now working continuously, and you've got multiple parts working in parallel, so you can have a whole sort of like production line working in tandem, almost on an autonomous basis. Okay, so to wrap up, what does good look like? So good in the future means safe, remote first decommissioning, regulation aligned with innovation, robust cross-sector collaboration, which I think is super important, and the UK leading the world for robotics in hazardous operational environments like nuclear. So I've got a QR code on here as well. It links out to the horizon scanning report that we've just published on robotics as well. So there's more in there about where we aim to take this in the future. So that's the end of my presentation there, Sam, and I will take questions later on. Thank you.
Fantastic. Thank you very much, Rav. That was really insightful. So at this point, we're handing over to Samir.
Excellent. Good afternoon, everyone. My name is Samia Nifty-Maziani. I'm Professor of AI and Robotics at University of Birmingham. I'm also the Director of the Robotics Institute and also the Director of the Hub for Circular Manufacturing System. Thank you for the opportunity to present today. My presentation will focus mainly on the challenges and opportunities for the UK to develop a world-leading RAS industry focused on circular manufacturing materials. I thought it would be good to start with this slide just to show you the scale of the problem we're talking about here. As you could see, the volume of high-value product needing end-of-life processing is rising at an alarming rate. For example, just to take a few, UK and at EU, we're expected to decommission 2,000 tons of wind turbines blades per year by 2030. And just the UK itself is 235,000 tons of EV battery by 2040. This is an example of just two products. Therefore, we need really to transform how these high-value products are processed at the end of their life. And more importantly, we need to ensure to retain the value of this product, especially given that we are relying massively on critical materials coming from outside the UK. At the same time, unfortunately, the current value retention process for this product are all labor intensive and have a very low level of innovation and technology. There's a little cross-industry collaboration with significant sustainability concern. This really is, of course, a cross-sector problem, with all manufacturing sectors increasingly having to consider how their products are processed at end of life. Therefore, there is an urgent need for the UK to develop a smart machine for value retention processes. What I mean by value retention processes here, we talk about repair, remanufacture, reuse, recycle, repurpose, and so on. If we don't act, the UK's energy transition will be more challenging to challenge. And also, future industry planning will be very difficult and might see high value of product manufacturing move to other part of the world as well. Sorry. Can you see? Now, if the UK if the UK were to fully embrace circular manufacturing, there are enormous potential economic and environmental benefits. We can see here some figures on economical, societal, and environmental benefits. Those figures are taken from different government reports and white papers, which are there, and highlight the potential impact of the work we are doing. I'm pleased to say that I'm currently leading a £30 million hub, which is bringing world-leading universities, local authorities across the UK, as well as industry, to address those challenges. We have set two grand challenges here. We want to radically transform the sustainable use of critical materials and also radically improve productivity of those manufacturing processes. Our vision is very clear. We want to create a more sustainable manufacturing sector that secures the UK's supply of critical materials and help drive as well forward the net zero agenda, which is really important. Then by leveraging AI, robotics and automation, we are creating here a new manufacturing ecosystem for circular resources, use of these high value products. The smart machine, AI technologies and robotics that we are developing will automate these value retention processes and will hopefully be also more economically efficient, faster, and more importantly at scale, and able to retain more critical materials and supply components back to the supply chain. The main objective are four. The first is to establish the ecosystem for the circular manufacturing. We want to create more effective smart RX processes. And also we want to develop these smart systems that are robust to variation, because we are dealing with different type of products here. We want as well to support designers at the onset of the circular process. This slide shows the different research areas that we are tackling as a hub. Then we have 6 different areas which are really key for these to advance, really to build those future smart machines. We have cyber physical inspection, sensing and analysis. We are building and exploring the use of collaborative disassembly in different value retention processes. We are building technologies for hybrid manufacturing and also future smart machines for autonomous material separation and recovering. But we have also a program which is not technical, focusing more on regulation, testing and validation, designed for minimal life cycle impact as well as circular business model. Now, to demonstrate impact, we are working with the industry and challenge holders on 4 real world cross-sector industrial flagship. The first flagship here is focused on energy because it's a very large part of the economy. Then we are working with the nuclear sectors and also the processing of batteries at the end of their life. Some of the challenges including, as you could see, handling, separation, extraction of waste in process with reduced carbon footprint. We will also be looking at developing life extension technologies for energy structures that are currently difficult to repair. We have another second one, which is a medical device flagship, which focuses on the challenges in processing medtech products. Again, as you could see, NHS spend a huge amount of money in this area, and the scope for this flagship project is related to the collection and recovery of medical waste associated with the treatment of roughly 3.7 million diabetes patients in the UK. The third flagship here focuses more on electrical drive and power train that will be exploring the challenges of disassembly of magnetized component, for example, rotors with strong magnetic fields. We are also looking at the problem caused by the widespread use of varnishes and epoxies that make automated disassembly very difficult. We are focusing on the separation of composite that can be dangerous to dismantle manually. That's another challenge that we are as well addressing. The final flagship, which is focusing more on large structures and is looking at the challenges in aerospace disassembly of high-value aircraft components and also of wind turbines, which have complex and variable geometry and make extensive use of composite components. I really see the transition toward circular manufacturing could present a real opportunity for the UK, economically, environmentally, and strategically. Unfortunately, achieving this transition will require addressing several critical challenges. This will include the high cost of end-of-life processing, limited domestic processing capability. Regulation is key, which we will hear after from Pav, presents a barrier to development of these robotics and autonomous systems, and the lack of circularity consideration in product design. A key question remains really, who should bear responsibility for end-of-life processing? Should it be manufacturers, users, or recyclers? Equally important is to determine how waste materials should be collected, processed, and reintegrated into supply chain again. Currently, the UK often exports end-of-life products, as we know, for processing abroad and then imports the recovered material back into the supply chain. This approach not only reduces economic value captured domestically, but also raises concerns about supply security and sustainability. Then to conclude, I believe through cross-sector collaboration, technological innovation, strategic policy support, with the strategic policy support, the UK has a unique, I think, opportunity to lead globally in circular manufacturing and secure a sustainable supply of critical materials for the future industries. We must develop clear regulatory pathways. Standards are key, and also guidance to support the safe and effective development of robotics and AI circular manufacturing. At the same time, industry will need support in areas such as workforce skills, leadership, return on investment assessment, and technical capability development. This concludes then my presentation. I would like to thank you for your attention.
Thank you very much, Samir. That was brilliant. Just a reminder to everyone as well, please do put in any questions you've got, after the next speaker, we'll be opening up to questions. So at that point, I will invite Vaibhav to give us his presentation.
First of all, thank you very much for inviting me to speak here and with other esteemed colleagues to give you this presentation. My name is Vaibhav Puri. I'm the co-chair of the National Committee on Robotics Regulation and Standards, and I'm also the Director of Sector Strategy and Transformation at the Rail Safety and Standards Board. In the next 8 minutes, I'll try and set the scene more generally in terms of what the pathway will be for greater robotics deployment in the UK. I'll focus on three things: the state of play of robotics and autonomous systems, perspectives and key challenges, tell you a little bit about the committee's focus and journey, and then also, lastly, share some ideas emerging from the projects overseen by the committee. Before I begin, I think it's useful to paint a picture of where the UK is when it comes to robotics. We are number one for university research, number 3 for private sector investment in niche deployments, but 23, 24 in actual deployments. I think deployments of robots per 10,000 manufacturing workers was somewhere around 230 or something like that, compared to other countries where it's significantly higher. So there's really a challenge here in terms of deployment that we have to deal with. It's not the tech problem, it's an issue of deployment. But 3 quick perspectives. First, 3 simple pathways for greater deployment. How do we make a technology cheaper? Does it become affordable? And what is the pathway to doing that? And in most cases, there is this pathway from early invention and development all the way to mass adoption. A technology first appears in a lab, universities and startups, then in high-cost niche use, with government and companies adapting it for specialized applications, standardized interchangeable components develop, supply chains form, learning rate improves, industry standards compatibility, interoperability, and cross-acceptance becomes a real challenge. And last but not least, demand drives production and consumers have access to the technology. In most cases, we are somewhere there in invention and early development and also early deployment. The challenge really remains how to get into scaling and create competition, and last but not least, really move towards economies of scale and mass adoption. The second perspective that becomes essential is really how to think about robotics and autonomous systems. Robotics and autonomous system as a technology, which is about the underlying innovations that helps autonomy and robotics, acceptance criteria, safety principles, these things matter. Robotics and autonomous systems are a product, which tangible systems designed for specific applications, where you start thinking about regulatory frameworks, cross-acceptance, and last but not least, and very importantly, robotics as transformative change, where the perception of the public and co-workers becomes essential in deployment. We have to move from product assurance and acceptance to operational integration of autonomy. But last but not least, really move into market creation for autonomy as a service. That's critical. If you want to create a market, if you want to scale up, if you want to be world leaders, the creation of a market and the stability that comes with it is an essential aim. Finally, I think the most important thing here is really thinking about how does risk, governance, innovation, choice, and collective focus come into this? What is the role of collaboration? In most cases, when people are thinking of implementing an innovative solution, such as robotics and autonomous systems, you start from a position of flexibility where you have full choice and full of lots of uncertainty. You move towards a stable method of design, move to a situation where it's cross-accepted across multiple sectors, and then individual sectors make choices within boundaries. The key thing here for robotics is moving from the magical to the mundane, and really thinking about the 80-20 rule. I was at a conference a few days ago, and there was a big discussion around how to make robotics completely modular, so that in most cases, the platform is largely the same, and only 20% of it is being adapted for specific applications. If we can get there, then that's a really important launch pad for moving forward. Now, moving into what the role of the committee is. The committee has been around for nearly 3 years now. It's a thriving ecosystem representing 16 sectors of economic activity, including government bodies, regulators, standards bodies, infrastructure managers, some of them listed here, and some people speaking today as well, my other colleagues. It's influenced policy for government across multiple governments, all the way from the beginning as a task force, but really providing specific reports to DCIT in particular on compliance pathways, what the challenges are for regulation, and really trying to create the ground principles and identifying the barriers that need to be overcome for robotics to really thrive. This has been possible by working with over 200 experts across the 16 sectors. We have access to 12 regulators, public agencies and infrastructures, and the committee is chaired by myself from Rail Safety and Standards Board, but also from UK NNL, HSC, and of course, Samia providing the academic leadership through University of Birmingham, and Innovate UK Business Connect providing support. The key thing that came out from most of the previous work we've done is specific statutes and regulatory mechanisms can often be perceived to be a barrier, but also can be real barriers also. There's often incompatibility and misalignment between different regulatory bodies that can always lead to perhaps a greater risk perception of implementation of robotics. And for innovators out there, they don't want to navigate this complex landscape without any support. The committee tries its best to provide that support, but perhaps this pathway has to become a little easier. The approach of the committee certainly this year has been to work specifically with individual projects. I'll talk a little bit about the 3 main projects. Engage with them, trying to do regulatory deep dives and really pull out some recommendations, next steps and lessons, both for the sector more widely, but also for government. 3 very, very exciting projects really that we are keeping an eye on and are involved with. The first is Milton Keynes Roboparts, which is all about licensing robotics, writing to robots in the public domain. Rescue MScare Sandbox, which Samia talked about quite a bit, but really exploring automation for a circular economy. And last but not least, focusing on an individual sector in rail and really trying to see, can rules and standards for autonomous systems be improved so that there's an openness to that innovation being implemented. Robopass, an incredibly exciting endeavor. Really, it's about establishing a usable local authority licensing framework. We're working closely here with Milton Keynes Council and Smart City Consulting, and of course the committee itself. the big focus is there's a real challenge of lack of relevant standards, lack of a framework and an approach that allows individual councils to provide access to robotics. And obviously, there's some challenges associated with legislation that can also needs to be overcome, and providing some kind of common assurance framework. The next project is working closely, as Samia set out very nicely, the enormous opportunities in the circular manufacturing economy. A little bit of work is being done very closely working with HSC to come up with a sandbox approach which can be repeated to really see how regulatory challenges can be overcome and the market can be stabilized and really can thrive. And last but not least, my company, the Rail Safety and Standards Board, is looking at rules and standards that can change the way robotics is introduced. So you see a picture on the left, that's a trolley, a human-propelled trolley. And what needs to be introduced really in some cases is an autonomous robot on the right, which is incredibly accurate, far more precise, and can do far more measurements than perhaps the manual trolley can. But at the same time, I think it's important to also recognize it's also a changed way of working on the left, where there's human beings involved in deploying and really measuring stuff, all the way to an autonomous implication, where at night and in adverse conditions, the robot can be deployed and it can actually do the work and do it more precisely. The big challenge, the rules often assume that a human being is involved. For example, the definition of a trolley is hand-propelled, thereby making it difficult for innovations like that, which have been proved and tested to be deployed at scale. To conclude, I'll share a couple of interesting outputs, certainly from the first project, RoboPath, which is very exciting. I talked about the need for common terminology, ontology. This is a bit of work being done to really think about what public space means, what public jurisdictions mean, what private jurisdictions mean. Milton Keynes is very lucky. It has redways, which are essentially under the purview of the council, where potentially pavement robots can be deployed. We really need to think about what a robot way looks like. And this is a way of really thinking about how legislation should be sliced up, and robot way definitions very, very clearly, where it sets out a very clear pathway where robots can go, and that makes a huge difference in terms of market opportunities for these companies. And also, last but not least, this aspect of robotic permitting framework, really thinking about giving permits for testing, permits for pre-commercial permit work, permits for doing activities. So a robot moves, that's sort of level 1 permit, testing it. And last but not least, really thinking about what commercial deployment permit requires. This is fundamentally around giving licenses to those providing robotics or autonomy as a service to the council. I just want to leave you with this final statement. Really, we are championing a new narrative, the journey of robotics from magical to the mundane. And unsurprisingly, that is through supportive cross-sector regulatory and standards frameworks and collaboration. Thank you very much.
Thank you very much. And thank you to all three of our speakers. I think those have been some really, really useful presentations that's certainly given us a good oversight of the area. So moving on to Q&A at the moment. There haven't been any come in yet, so I will start it off. And the assumption people are being shy. So another little plea for people to put some of your questions in. I'm sure people have them. So, I mean, some of you talked a little bit there about sort of regulatory frameworks and other things that you want to see government do. I guess this is a question to sort of anyone really, but what would you say the key things that politicians and government can help with are to try and kind of further the work you're trying to do in the sector?
I'm very happy to start there, Sam. Thank you for the question. I think a recognition that people who are trying to break into markets and particularly areas where robotics isn't as commonly deployed is support for the innovators, really. Committees like ours and really pointing them in that direction. So support can be provided. I think that's one of the most important things. Regulations and legislative landscapes can be complex, and not everybody has expertise in that. And if expertise in the regulation essentially becomes a competitive advantage, then that's not helping the market, really. We have to make it simpler, and we're very, very happy to work with politicians to come up with proposals to do so, certainly as a committee.
Anyone else want to add to that?
So I'm happy to add on to that as well. So yeah, I completely agree with what Vaibhav was saying there as well. So I think regulation, absolutely, and I think we're making good headway, with our regulators on that already. But I think that overhaul of, where do we aim to be as a country in the next 5 to 10 years, and where are we today, and almost like bridging that gap as fast as possible, is something that I think we should be investing in, as a country, and just almost recognizing that when we're talking about autonomous systems as well, it's the computing power that kind of goes with it as well. So today, when we're using cloud systems, some of that is in the UK, some of that is overseas. What do we want to do when it comes to sovereign AI capability as well? So we can sort of protect that ourselves, and where does that investment sort of come in? So it may not all be government; it may be government with the private sector, but it's probably something to just give a bit more thought, as we move forward. And as Vibo was saying, that whole sort of like cross-sector working as well. When you take an objective view of some of the challenges that we've got, they're very similar. So I think just trying to merge that together, I think, will help us move forward in this space. And because we're a sort of like service country as well, I think we can offer this as a service going forward, when it comes to what we do globally.
Thank you. Samir, did you want to add anything?
I think my colleagues have said really stuff I wanted to add.
Great. No, that's really helpful. So we have had some questions come in now. The first one, I think the person's must have ticked a box to make themselves anonymous. So I don't know who it is. But we've got some questions from Irfan, who we'll come to in a moment, but someone else has sent a question. Does that person just want to identify themselves somehow? If you pop a message in the chat or submit a further question so we know who it is. While they're doing that, perhaps we'll go to Irfan. So Ben, are you able to unmute Irfan?
Yes, he should be there.
Great. And then Irfan, you can ask your question.
Yeah, hi. From my side, I've got two specific questions. One is regarding the robotics and design life before the chips and whatever become obsolete. What's the situation with regards to this and with regards to newer technology superseding what you already have? So, in terms of costs, I guess as the first question is asking, will it become cost prohibitive? What is the cost benefit analysis? How do you make that judgment? And the second one, with regards to Sellafield, I worked at Sellafield before. So a lot of the issues we used to have was linked to radioactive exposure and that sort of implementation on the site. So how is the Sellafield site overcoming that sort of natural issue?
Can I just also say, I should have said at the start, so forgive me. When you ask a question, could you just let us know which organization you're with as well?
Oh, so I'm with technically with IOSH. So I'm working indirectly through IOSH.
Thank you very much. Who would like to take that?
Happy to say the second part of the question for Irfan. So thanks. Yeah, really good question. So yes, when you put in any sort of electronics, as you know, into a nuclear environment, you have got the potential for it to, not behave in the way that you want it to do. But I think what we've started looking at right now is not just trying to throw ourselves in at the deep end and saying, right, we want to put this into the most hazardous environments, and let's have a look at how we create a robotics and autonomous system that works there. But we've gone for where can we actually make a real difference today, and what do those environments look like? So if you take some of the underwater ROVs, which I think must have been there when you were working there as well, Irfan, we use those under in our radioactive ponds, and we do coat them, we cerakote them, to help sort of like protect them against radiation. As much as possible. Of course, you're going to get some damage over time, but what it does do is sort of like mimic it. And we're continuously working with our supply chain partners and the national labs to try and look at what else can we do to reduce and harden the components that we're putting into those environments. So that R&D is continuously going. But when you take, say, quadrupeds as well, we put those into radioactive environments where we would normally send our workforce, you know, and operators in an air-fed suit, you know, so they're in those sort of like plastic suits going in, you know, for a limited amount of time only. But what we found is, you know, quite surprisingly, that it's working, you know, without any issues. You know, we're able to like send them in, keep them in the environment. You know, their charging docks are there as well. It's collecting information real time, sending that back to us. You know, on the other side, on the clean side, and we've not seen any issues with that just yet. But what we are doing is working with the manufacturers there as well. So any data that we've collected in terms of how much radiation tolerance that robot system can tolerate is then being shared back as well. And what we found is that, look, we want to be the testing ground, the proving ground for some of this type of stuff, because no one else has tried it. So if we try and answer the question, let's get the answer from another organization who's done it. Our environments are quite unique. So actually, I think we need to be the ones who do try this, you know, first off, and that's what we're doing. And luckily, I work amongst team members who do want to take that initiative to push forward on that.
Right, thank you very much for that, Rob. Does anyone want to come in on the first half of Fan's question?
I'm happy to do so. Now, Sam, I think it's an interesting question, particularly around technology development and obsolescence, and keeping an eye on that, and the potentially sometimes high costs of robotics introduction. I think that remains a challenge, really. I think the big question is really creating a market. I tried to sort of answer that in the presentation. Scaling and cross-sector deployment has to matter. So if people are making robotic platforms that can be deployed across multiple sectors, then that core platform starts to, suddenly the economies scale start to work in the right direction, and the costs start to reduce also. Keeping an eye on technology will always be challenging. I think the convergence of where robotics is headed, where AI is headed, and even quantum for that matter, that convergence is going to come at some point of time. And keeping an eye on that matters massively. I think, which is why it's essential that any regulatory approach that is in there is open to that innovation. It doesn't shut down options for the sector, but it also empowers. Certainly, I mean, I'll do a plug for the committees like ours to keep an eye on what is changing, so that we can keep an ear to the ground, understand what deployers are struggling with, and really see what can be done to make that life easier. Really, I think that that centralized support has to matter. If the UK's general vision is for UK to become a leader in this space, then some degree of centralized support will be required in this sector, because the barriers to deployment are challenging. But UK can certainly be a leader in responsible deployment of robotics in specific areas, and I think that can be an incredibly powerful positioning for the UK, certainly globally.
Thank you very much. Samia, do you want to add anything?
Yeah, if I may just intervene for the second question, which is about design life. I mean, if I understood the question, I think what I can share is more what we are doing within the hub as far as the life, for example, assessing the lifetime of the product in order to recover critical materials of high value. Those products, what we are doing is as I said, we are assessing before recovering. For example, the material, we assess actually if we do the life, material, the cost of the material, and also we are looking at the how, if the cost analysis allow to do that process of recovering, then we do it, we extract then the material, otherwise then we recycle. And I think what we need to say here is there are some softwares already which can define the cost analysis of the actual material that we are trying to recover. However, I think we need to look at it in a holistic way. We need to look at really the entire process and look at the design at the end, the design, how we can really design a product in a way that it's very easy to recover the actual product. And I think we are bringing people who are expert in the design, but also sustainability, and also material scientists who are aware of the actual cost. And it's a very complex formula. And I think what we need to do is the first time that we are really looking at that in a really holistic way in order to ensure that what we are doing is a cost analysis then with materials.
Right, thank you very much. That's a really comprehensive answer from everyone there. The next person we have to ask a question is Richard Roth. So if we could have Richard. And Richard, you can ask your question. Please go ahead.
Hello. Yeah, hi. Actually, some of what Samia has just been saying does respond to my question. I was interested in the statistic about 80% of perhaps the cost and the post-processing difficulties are actually locked in at design. I mean, the statistic flashed back quite quickly, but it chimed with me with respect to other aspects of use, whether that be risk, hazard, carbon, and so on. And to some extent, it relates to what Vaibhav was saying about modularity in future of robotics. I guess you would agree that we need to start engaging with designers because they have the best opportunity to make the most difference. And I guess taking something from a wild idea or concept to a product, there's the opportunity really to make our lives easier in future and absolutely to reduce our drain on the planet. But comments, I guess, rather than a question at this point.
Yeah.
Samia, did you want to add anything in response?
No, actually, that reinforces a little bit what I have been saying is we need to close the loop. I think once we look at the life cycle of the actual product, we have designers already looking at that and ensuring that the future design will take all the key parameters into account. And that's why I said it's quite a complex formula, really.
Okay, thank you very much. And just to add, Richard is the interest group chair at Hazards Forum because he typed that in the chat rather than saying it. So our next question comes from Ian Scott. So could we have Ian? Hello, Ian. Do you go ahead and ask your question?
Right, yes, we've unmuted. Thank you, good evening. I too am here this evening representing IOSH, the Institution of Occupational Safety and Health, which is rather just simply coincidental, I think. And this is not so much really a question, although there is part of a question in it, as more an observation. And I've sat here in awe for 45 minutes listening to 3 absolutely superb presentations. And it really has been quite insightful and very thought-provoking about what you're suggesting. My comment really is there's been strong emphasis on the benefits of enhanced safety and human factors work, etc., as well as commercial benefits and higher levels of sustainability. However, in my view, the requirements in terms of engineering and technology skills to address all the mechanical, electrical, electronics, physics, the chemistry, material sciences, etc., are huge. And I know this is principally looking perhaps at Sellafield. But it almost begs, will a super governance system be required to oversee this, also based on AI? You know, will we have the machines having to supervise the machines? It seems to be an enormous task you're setting.
I can kick off. I'm sure others will come in again. I think Ian, you're right. I think we are at a state where we are trying to for issues and challenges and use cases where robotics fits perfectly. You know, they'll get introduced as the systems start to get more complex. I think there's an interesting question around whether there'll be a sort of monitoring and supervisory activity. I mean, it's already coming to the fore in some of the work being done, certainly at Milton Keynes, where this idea of a control room and keeping an eye on multiple. If you imagine a future world where the market is very open and there's many robotics solution almost interacting, you will almost require a degree of monitoring of what individual robots are doing. So you will have almost a robot level monitoring aspect. There's that sort of a collection of robot question, and then there's network aspect, which is why I think one of the key things to highlight here is the need for infrastructure. I think which we should have said. You know, we will get to a point where nationally we will have to invest in some infrastructure, including, which I think in one of the recent conferences somebody called the Omniverse. You know, a kind of a digital twin that allows people to test things in a simulated environment. I think those two aspects and really doing that nationally, because that is not going to be possible. We can't expect individual councils to have that sort of infrastructure. So one of the challenges for government is really setting the scene and putting that infrastructure in place, because without that, I think we will run into difficulties, certainly scaling difficulties. And the other point you made about human factors, I completely agree. I think we have to think about the introduction of these things as a service, not as a product, have to think about it as change, because that's when the ethical aspects come together, and the human factors element. So this isn't about robotics. Robotics happens to be the technology. It's fundamentally around the change it causes and how we manage that.
There is one more person with a hand up. So do either of Rav or Samia want to add anything quickly to that one before I take this last question?
I was just going to say, Ian, that's an excellent question, and I don't think there's a short answer to it either. But I think it's probably one for another topic, possibly.
Samia?
Yeah, I think if I might add, is what you have highlighted, Richard, is absolutely spot on. And the problem is not if we have to do it. You said the challenge, we are raising the challenge really high here, if we have to do it, but when we need to do it, because we will be facing with those robots that will require really this collaboration between all the regulators and overseeing all those aspects and all those critical problems that you have just raised. And hence why, I mean, I gave an example about really disassembling batteries that will require, require several regulators, or and especially if you are they are in the workspace and you need HSC, you need regulator, different regulators to really understand and come and resolve this safety case of these challenges. Then I think it's a must, really. It's something that we will be faced with.
Thank you very much. So there is someone with a hand up, Caroline France, who I think we can take it very, very quickly. If we could possibly get Caroline on screen. Oh, her hand is now gone. Oh, hello, Caroline. Would you like to ask a question quickly? If we can. Oh. There we go. You've been unmuted.
Hi, sorry, I pressed the hand button by mistake. Sorry about that.
No worries at all. That's absolutely fine. Right, so in that case, we've come to the end of our questions. So can I just take the opportunity to thank all of our speakers, first of all, for Rav, Samia and Vaibhav for all coming and giving those presentations and those answers. And I'd also just like to thank Louise from the Hazards Forum, as well as our other contributors from the Hazards Forum as well. So that would be, hang on, I'm looking for names. That will be Mark McBride and Steve Davis. There we go. Thank you. Apologies. And also, just as always, to thank John Slater, who's writing up the notes from today into a report, as well as the PNSC team, Lee, Karen, Ben, and indeed John, who I've just mentioned. So our next discussion meeting in Parliament is due to be held on Tuesday, the 12th of May, in cooperation with the Nuffield Council on Bioethics. So thank you ever so much to everyone for coming today, and have a lovely evening.
Thank you. Thank you, Ben.